Hello, my name is Demján. I'm a co-designer of the Laser Edit Profiler, and this is an instructional video on how to assemble and use it. So the Laser Edit Profiler comes packaged in two main parts. It's the upper part and the lower part, this one. And you can see there are a number of cable connections which I will connect later when the lower part is already installed on the table. First, let's begin by fixing the lower part to a table. So as you can see, the mechanism allows for a relatively wide range of table sizes. So it's wise, if it's a glass table like this, to put some sort of protection. And we can continue to fix it on the table. So you can see it's easier to do when it's still disassembled as opposed to if it was already fixed together. It's fixed. Now the second part is connecting the upper part of the profiler. So you see it has there are points where the screws are attached on either side. So carefully not to pinch any of the cables. I slide it in like this. The cables go into the grooves on the sides. And now I take the screws. The other side. I continue to attach all the cables. You see there's USB cables going in the cameras. They have to be attached. So here, the second one, and the lower camera. There is the USB cable is separate. So I attach it first in the camera. And then there is a USB hub on the back side of the profiler. All the other USB cables. There is only one coming from the bottom side of the USB hub, which then goes into the computer. So that one will be attached to last. Now I attach all the cables this is from the laser projectors and from the light. Okay. If I were using the pedal, there is a pedal which comes with the profiler, then I would also attach it now, but for this demonstration I won't be using it. All the functions of the pedal can be also done with the keyboard. So that's the last USB cable. So now we can proceed to attach the glass pane, which will be then used for as a platform for manipulating the pottery fragments. So first I add this plastic fixture and align it with the holes in the glass pane, of course, so that it can be screwed on. So relatively tight fit, so you have to be careful. if it goes too hard, then it helps to move the plate around a bit. So, up, down, left, right. I will attach, there is just one USB cable with which it is attached to the computer, so I'm gonna connect it now. Ideally it would be to use a USB 3.0 cable, but it works also with a 2.0, which is the case in this time. So to be able to calibrate the device, we have to first make sure that the laser lines are aligned. There are two laser projectors, one from the top, one from the bottom, and the lines form a plane, which has to be aligned to the cameras. So this is now the software to the laser aided profiler opened. I click on the calibration icon. And here you see a set of icons to turn on and off the cameras, the laser lines, and the lights. So first I turn on both laser lines, and now you see the laser lines. I can use this paper to visualize them. They are a bit misaligned. That can happen during transport and so on. So the first thing is I have to make sure that each of the laser lines is projected exactly in the middle of the opposite projector. So I check the upper laser projector is illuminated by the lower one, and we see the line going exactly through the middle, through the center, so that's okay. But looking at the lower one, we see that the line from the upper one is mismatched. So I have to. There are four screws on each side of the mounting of the laser projector. I have to loosen them a little. It's not too much. Just so that I can move it. It's very slight movement is necessary. So it aligns. So now the laser line is projected directly through the middle, and I can also rotate the projector slightly to align it. So now I tighten it again. So that's the first step. Now to make sure that both lines are aligned with the cameras and with each other, so I put a paper here. It can be any dark matte piece of paper, and I turn on the upper camera, and we see there's the laser line as the camera sees it. It's a bit crooked, or it's a bit slanted. So I can use by clicking and dragging on the image. This is the crop function, but I can also use it to have a ruler, and I rotate the upper laser projector until the line is aligned with the. You see, it's a bit. It has a bow, but that's normal. That's the lens distortion, which is then corrected by the software. So it's supposed to be like that. Now, for the lower line, the same. Again, we see it's. I can adjust the exposure to see the line better, and again I can proceed with aligning it with the monitor, with the camera. Should be fine, and theoretically the lines should be also aligned to each other. I can use the calibration pad to check it. So I insert the calibration pad into the laser line. So there's these protrusions on which the lines are both projected, and I can check whether the lines are matched. I see they are not in this case. So I have to slightly rotate the projector. now the lines are both aligned, and we can proceed with the calibration. So I will leave the calibration pad here. It has to be exactly, or at least exactly enough in the center of the glass plate, and you can see on the camera image that all the protrusions have to be visible. So I can adjust the crop marks a bit, and from the upper camera too. Switch to the upper camera. So all the protrusions are visible. They form, the laser lines form something like arrows on them on which the calibration function will focus. So now I can also adjust the exposure a bit to provide the best contrast for the camera. And I click on the display or capture calibration points, 5 calibration points icon, and you see these green dots, green circles. They show where the calibration points have been detected, and it helps to adjust the exposure so they are properly detected. If I'm happy with it, it'll take a while. Then I click the function to store the calibration points, and I do the same with for the lower camera. So again, adjust the exposure. To detect the calibration points properly, we might need to adjust the exposure and also make sure that the parts of the laser line are not visible. So for example, here we have a reflection on the glass pad, so I can move the crop mark a bit higher, and now we see that all the calibration points are captured properly. I can click on store calibration points, and with that the calibration is complete. I can now again click the calibration icon to switch to the regular mode and turn on the capture profile mode. And here I see that the calibration points are captured properly. So let's turn this off, and now we can proceed with working with the profiler. It's calibrated and ready to function. So now we can proceed to some display of basic operation of the profiler. First, we will just go ahead with a simple profile. Let's say this fragment. It's done using the function capture profile. So we switch to the mode, and we see right away that there's something being recorded. It's a live stream from the profiler. So we can check with the calibration function. I click the calibration function, turn on the upper camera. The laser lines should be turned on, and I see that there's some reflections from the glass pad which are being picked up by the cameras. This can be corrected by using the crop envelope here, by clicking and dragging it with the left mouse, and also the same for the lower camera. We see the laser line is being picked up, so I can left click and drag the crop envelope and mask it out. And you see, if I hold the pottery fragment, the profile is still being picked up. Also, I see the exposure is set a bit too high, so I can dial it down. So just my hand shouldn't be visible. Just the laser line should be visible to the camera. Like this. Also for the lower camera. Okay. Should be all set, and we see already the profile is being captured. You see there's this some noise, but it's due to the nature of the laser line. This is about the normal amount that you will get. You'll see some spike, maybe we can adjust the exposure a bit more, but okay, no, I just made it worse. It needs to be set up at the beginning, and you will see that as the light conditions during the day change, this will also have to be adjusted. Hopefully there still seems to be something undesirable. Okay, let's capture the first profile. I clicked capture. Now you see the profile is a bit jaggy, so we can use the smooth function here to smooth it out, adjust it a little. Okay, and also I have the profile should be on the right side, and the fragment is oriented like this. So I use the flip horizontally function to correct it. Now I can use by right clicking and dragging, I can change the orientation of the profile. So this is the part when one has to have some expertise on pottery to be able to orient the fragment properly. There's no technical way to do it, at least not for now. So okay, we have oriented the fragment, and now we can proceed to take the diameter. So the diameter function is this icon. I click it, and here you see what the upper camera sees, and I have to place the fragment in the laser line so that the line illuminates the part where I want to take the diameter. It captures the arch, and the software recalculates calculates the diameter of the vessel based on this arch. So if I'm happy with it, I click capture, and I have to tell the software where the diameter was captured. So here, and now you see the basic form taking place. It's taking the form. Now I clicked the rim, so this indicates that the fragment has a rim. Now you see automatically the diameter is expressed here in centimeters. Now I can add some inflection lines with this function. Like this, we see there's some lines in the profile. It's also to the discretion of the whoever is drawing, the archaeologist, from the inside. And I can also add some break lines like this. I left click on the profile. You see the cursor automatically snaps to the profile. I left click, and as I move the mouse, I can adjust the inclination, the position of the break line, and then left click to place it, and again a second break line. And you see automatically a break line has been placed on the outer profile. So this is how common drawing is done. Also, I can use there is a camera function. So I click on the capture photo function, and here you see what the upper camera, there's a color camera, sees. And you see there's a lot of undesirable things in the background which you would like, so it's advisable to use some sort of background. Also you can have different colors, of course, if it should provide enough contrast. And I can adjust the exposure. I can also decide whether the lamp, because you see that the lamp has automatically engaged, so I can decide whether I want to take the picture without the lamp and just with the natural light, or use some my own light, or maybe this fragment should be propped up a little to take the photograph. So I need something to prop it up like this. And now we can adjust the threshold. There's an automatic outline function that will crop the photograph. So by adjusting the exposure and the threshold, I can crop it. So let's say like this, capture. Takes a while, it has to correct. So the photograph is automatically corrected for lens distortion, and it's photographed in the proper resolution. So now I can place the photograph in the drawing like this. Okay. So this is the basic operation. There are other functions for more complicated shapes. For example, if we have a shape that has a handle, it's a closed shape. So let's see if clear. If we try to capture the profile of it, it's you see the lasers cannot be projected on the inside, so it wouldn't be possible to properly capture the handle. So for that we have the capture handle function. I can set it up here. You see again, this is view of the upper camera. This is again the crop envelope, which you can adjust as you need. I just place the fragment here. Maybe I can turn off the lamp again, and I can use the threshold, adjust the threshold so the outline of the handle is captured properly. For this, I don't have a brighter background, but we should use a less dark background maybe to achieve better contrast for this particular type, or maybe softer lighting. But let's capture it. So I can capture a handle like this, and then also add the other details like profile. Let's see, the profile is best taken here just under the handle, but it shouldn't be a problem. I can show you how it's done. You see the handle is captured here together with the profile. But what I can do, I capture it, and I can use the trim function here. It shows the cursor, again it snaps to the profile, and I can left click where I want to start trimming, and then just drag along the profile, and again left click, and it will just trim away that part of the profile. Again right click and drag to orient the profile. In this case use the flip function to flip it to achieve the proper orientation. It should be about like this. Smooth it out. And measure the diameter. Again, diameter function. The diameter can be without a problem also captured on the inside of the vessel, as you can see here. It's only advisable to use here the crop envelope, because you can see that there's some interference here. The lacquer is causing some problems to the laser, so I can just use the crop function to crop out all the parts of the image which are interfering, and you see I'm capturing a nice arc here. Okay. Now capture. Click on the inside of the vessel. We have a rim, and the brake lines, and we can adjust the position of the handle. Also trim it with the trim function. Moving is done by left clicking and dragging. Okay, and maybe some smoothing. Everything can be rotated by right clicking and dragging the mouse. element. So this is the handle function. Also here I have only complete fragments, but in case we have a fragment which would be consist of two shapes, of two parts. Let's say it's broken and we don't want to remend it. So let's simulate that on this fragment. So I take the fragment, capture the profile, and let's say it was broken up somewhere here. So I can simulate a broken profile by trimming this one like this. Okay. So now let's say I want to capture the lower part. So again, I clicked. We have this detail function which can also be used for capturing any details like knobs or anything that's on the profile, and we want to edit additionally. So let's capture it as a detail. Capture. Again, crop it. Okay, and now we can align these two parts of the profile. So by left clicking and dragging, we move it, and by right clicking and dragging, we rotate it. Now if it's aligned, I can hold the control key and click to select multiple elements. Now those two, and I use the trace function here. I click it, again I see the cursor, and we can, if you left click, you start tracing. You just drag the cursor along the profile to automatically snap to the profile and trace the profile. And now I can choose to save this trace as a profile. I click OK, and I can rotate it, select the detail that I have captured, and can delete it, and now I have the complete profile again. This one should be probably also flipped, oriented, and work with it as before. So this concludes the basic operation of the profiler. I hope it will make your life easier, and wish you a good day.